Hello students, in today's session we will discuss few numericals related to Kirchhoff's laws and Wheatstone bridge. Yeah. Yes, okay everyone. Yes, quiet please. Did you learn fast? You're getting my voice last rows? Can someone bring the speaker? No, my table, right? Right? So, few simple questions only. We'll discuss maybe 30 minutes to understand how to apply especially Kirchhoff's laws, based on Kirchhoff's laws I can say. Okay? And maybe related to Wheatstone bridge as well, one or two. But basically, mainly, how to apply Kirchhoff's laws. We try to understand with few simple examples. Right? So already we have discussed about the sign convention, right? So do you remember the sign convention part? So by using that and Kirchhoff's laws, how to find specifically the potential difference between 2 points? Let's try to work out few questions, especially these kinds of questions are asked in some of the previous years of NEET as well. So don't neglect this as simple questions. Okay, try to work out every question. Before that, I would like to once again recollect back that whenever you have given a battery, what does the potential difference of the battery and cell? What does the potential difference means? Say for example, if I have this is a cell having some potential or EMF of 3 volts means the higher potential minus lower potential should be equal to 3 volts. That is the meaning of it. Right? So here if say if there is an example, if it is given that there is a cell having potential difference of 10 volts, it is connected to two terminals A and B and B. That means if you say this is higher potential, lower potential, potential of A minus potential of B should be equal to 10 volts. Now that means here you can say simply potential at point A is nothing but 10 volts. Potential at B is how much? 0 volts. We call this as higher and lower potentials. And already a number of times I told that here usually we represent higher potential with the plus sign, lower potential with minus sign. That doesn't mean that this should be a negative potential and this should be positive potential. For example, if you consider, you can note down this as a running notes every point so that it can be helpful for you guys. If we have a battery, same battery of let's say 9 volts. 9 volt battery is the cell provided. This is higher and lower potential. This is point A and this is point B. Here, if VA, potential of A is let us say 11 volts, then what should be potential of B? What should be potential of B? So this 9 volts means VA minus VB is equal to 9 volts. So where VA is 11 and minus VB is equal to 9 volts. So minus, if you bring it here, you get VB is equal to 11 minus 9, 2 volts. So here you can say this is VA is 11 volts, VB is 2 volts. Both are plus, this is positive only, this is plus 11, this is plus 2. Both are positive values only. So lower potential here, negative, we have represented negative potential with a negative sign, doesn't mean that should be negative. In this case, in case of a battery of 9 volts, if the higher potential is at 11 volts, the lower potential will be plus 2 volts. So lower than that, another terminal. That is the meaning of it. Say for example, another example you can see. Another example. Consider here, there is another cell with terminals A and B only. Let us consider the potential of this is same 9 volts, 9 volts, and potential of, in this case, potential of A is minus 2 volts. Then what is potential of B? VA is minus 2 volts. You know that is higher potential, is lower potential. Higher potential is negative. It is given here as negative potential. So what should be potential at B, point B? Minus 11. So the difference between these two should be VA minus VB should be equal to 9. So VA is minus 2 minus VB is equal to 9. If you want VB, bring it to that another side, becomes plus VB. Bring it here. Minus 2 minus 9 becomes minus 11 volts. Minus 2 volts. So this is VB is equal to minus 11 volts. So is this is higher potential? This is higher potential. Minus 2 volt is higher potential than minus 11 volts. The number, when you are dealing with the negative values, don't look at the larger number. Minus 11 is higher than, bigger than minus 2. No sir, this is not the meaning of that. Actually, when you are going to the negative cycle, and if your negative values are decreasing, the value will decrease. We are going higher values of negative values. You know, what is that? Ascending values of negative values will give a decrease in value. So this is at higher potential, that is a lower potential. Minus 2 volt is higher than minus 9 volt. Is it clear? So these points you have to remember, keep in mind while doing with these dealing with the Kirchhoff'S laws. Now write down another example. As I said, these are very simple questions only, but it will give you little more understanding. So it is given that there is a resistor which is connected between two terminals A and B. So the resistor is having a resistance of 5 ohm, and in this a current of 2 ampere is flowing, so that the point A is at potential of VA is equal to 2 volts. Then what is VB is the question. What is VB? Yes guys. Try yourself. Try yourself. Already this kind of question I have discussed in Y section. Minus 8. Let me check my answer. Others, any different values? By using those sign conventions, if you apply, it is a part of a closed loop, actually speaking. It is a part of a closed loop, so we can apply, what is that? Kirchhoff'S voltage law, KVL. So, as current is flowing from A to B, you can say this is a diode potential, VA. So, as current is flowing from this side left to right, this is said to be a diode potential, this is said to be a lower potential. So, I have to say usually always current flows from higher to lower potential. Plus to minus. So, this is potential drop across, this is nothing but IR. So, you can say minus IR, and this will be lower potential B, so minus VB should be equal to 0. That's what about VB. So, send VB that side, then you can write it as equal to VB plus VB. So, VA minus IR. VA is how much? 2 volts. Minus I is 2, R is 5. So, minus 5, 2 into 5 is how much? 10 is equal to VB. So, VB is equal to minus 8 volts. Is it clear? Right, everyone? Copied. Next. Any confusion, guys? Next, note down. Similar one only. So I want the answer from everyone now. Let us take. There is a resistor of 2 ohm and a current of 2 ampere is flowing here. This is A, this is B. So here VA is equal to 2 volt. What is VB? Yes? 0? Minus 2? How many got 0? How many got minus 2? It's down. So the same, what is that? You have to start from A. As current is flowing in this direction, you have to take it as higher potential. Okay, so VA, as current is flowing through the resistor from left to right, this will be at higher and this will be at lower potential. You have to mark. So potential drop across the resistor is IR. I is this, R is this. So we are going from plus to minus. Take minus. Minus IR. I is 2, R is 2. 2 into 2, 4. Minus 4. It is lower potential. So you can directly take this as equal to VB. Minus VB equal to 0 or equal to VB. So VA is 2 minus 4 is equal to VB. VB is equal to what? Minus 2 volts. Got it? Any confusion? That's it. Clear? Everyone? Next. So I have dealt with one single resistor case. Well, let us say 2 elements. If you consider 2 elements, 2 circuit elements means like 1 resistor, 1 cell, or given 2 different resistors, 2 different cells, okay, different combinations. Let us take another one. So if we have a resistor and a cell, which is where resistor is having resistance of 2 ohm and this is having a potential of 5 volts, potential difference of 5 volts. Now here a current of 2 ampere is flowing from, this is A, to B in this direction. Yes, this is your B. So if VA is equal to 10 volts, then what is VB is the question. Or sometimes you simply ask me to find what is VA minus VB also, without giving VA. Okay? So what is VA is this, what is VB is the question. minus 1. Same. What is that? Kirchhoff'S voltage law. Yes. Listen. As current is flowing in this direction, this is VA, and current is flowing from left to right. For the resistor, left side should be plus, right side should be minus. So, as we are going from plus to minus, potential difference across resistor is negative. How much is this? I is 2, R is 2, 4. Next, for a cell, this is higher potential, this is lower potential. Irrespective of current, we are going from plus to minus, should be minus only. Its potential difference 5. Lower potential minus VB equal to 0, or you can see it is equal to VB. So you understand? Now VA is 10. So it is 10 minus 9 is equal to VB. So simple. How much? Got it? Everyone? Next one. Can you try one more this kind of? Yes? The numerical values you can take any question. How to deal with? Yes, let us consider here we have a resistor and a cell, another example. And the resistor is having a value of again you can consider this is if same resistor, 2 ohm resistor and 5 volt cell we have, and same current 2 ampere of current is flowing here, but the potential, this is A, this is B, but potential at A is 4 volts. 4 volts. Then potential at B is how much? Minus 5. Yes. So VA minus 4 minus 5 is equal to VB. So VA is 4. Minus plus 4 minus 4 cancel out. So VB is equal to minus 5 volts. Right. Now let us see next 3 or more elements kind of circuits. Have you copied this, everyone? You copied? Yes, guys. Right. Look. So next, note down another example. See, there is a point A. Here, a resistor of resistance 2 ohm is connected to a cell of potential difference 4 volts is connected to another resistor of resistance 2 ohm only. Then it is connected to another cell in reverse polarity, which is having a 10 volt potential difference. It is connected to point B. But here the current is flowing from B towards A. Current is flowing in this direction. A current of 5 ampere is flowing, guys. 5 ampere is flowing. Okay? So you are asked to find what is the potential difference between A and B. What is VA minus VB is the question. VA minus VB is the question. So you can start from A only. You can start from A only. Sorry?
Minus 26.
Minus 26. Any other answers? Any other answers? This side? VA minus VB. You can start from A. So this is VA. Let's take it as VA. We are going, current is flowing in this direction. First give the sign convention for all. For batteries anyway, higher and lower potential, this is higher, this is lower potential. For cells okay. But for resistors, as current is flowing from left to right, this is higher, lower, plus minus, plus minus. Is it clear? When you are going from A, it is VA. So when you are going from A towards right means negative to positive you are going. So plus IR, I is how much? 5 ampere. So 5 into 2, 10, plus 10. And then here we are going from plus to minus, minus 4 volts. Then plus 2, sorry 2 into 5, 2 ohm into 5, how much? 10. Again here plus 10, as this is, yeah, so then it is, you can take it as you are going from A to B. A to B, you can take this as minus VB is equal to 0. You understand? So here we have 10 plus 10 plus 10, 30 minus 4, 26 plus 26. So VA minus VB plus 26 equal to 0, or you can take it as VA minus VB is equal to minus 26 volt. Here is the potential difference. Got it? Right. Next one. Let us see now a question from the exercise. Yeah. Level 1 exercise 2. Level 1 exercise 2. Or here previous ones. Level 1 exercise 1 we have discussed already, right? Level 1 exercise 1 I have discussed, I think in the voice I have discussed one question. No? Okay, then we see level 1 exercise 1. One simple question is given. Level 1 exercise 1. Right. Question number 52. Question number 52. The question is, the potential difference between A and B in the given branch of a circuit is. So we can note down the potential difference between A and B in the given branch of a circuit is. The question is, this is A. and it is connected to a resistor, then to a cell with a negative and lower and higher potentials, then to a resistor, then to a cell, then to a resistor, then to a point B. So it is 1 ohm, this is 2 ohm, this is 3 ohm, right? This is 9 volt, 3 volt, and a current of 2 ampere is flowing in this. So this is what is mentioned. We are asked to find VA minus VB is equal to what? VA minus VB is equal to what? Yes? Options, you note down. First option 6 volt, second option 12 volts, third option 9, and fourth option 0 volt. 6 volt. So as current is flowing, this is the direction of current, guys. So current is flowing in this direction, right? One thing is clear. Another thing is give sign conventions. For resistors first, as current is going from left to right, plus minus, plus minus, plus minus. Is it clear? Everyone? For resistors. And for cells as it is, this is the lower and higher, this is higher and lower. Okay. Now VA for resistor minus IR. I is 2, R is 1, 2. For the cell, we are going from minus to plus. So plus 9. Again here for the resistor, minus 2. Resistance is 2, current is also 2. 2 into 2, 4. Minus 4. Then for this cell, we are going from plus to minus. So minus 3 volts. Then for resistor, plus to minus. So resistance is 3, current is 2. 2 into 3, 6, minus 6. Minus VB is equal to 0. Right? Now we want VA minus VB. So you just observe this. Minus 3 plus 3, minus 9 plus 9, cancel out. Minus 2, minus 4, minus 6. So we want VA minus VB you bring here. Minus 6 you send that side, it becomes plus 6 volt. So option 1 is right. Got this, everyone? Right. Next question. So let us see, these kind of questions are given in next level 2 exercise 1. Exercise level 2 exercise 1. Level 2 exercise 1. I'll wind up in 5 minutes, guys. Okay? So any so online students, if your voice is not clear, our board is not clear, you can drop a message. There is got a message that one of those students got less marks. I'll speak tomorrow. Okay? Don't want to pronounce the name here. So are you following? Any difficulty you are facing? Or you want to go a little slow or fast? Yes? So because you are all repeaters. So by keeping that in mind, few basic things will go a little fast. If you are not following, you have to tell. Okay? So next question, see here. the circuit shown in figure, the current I is, the circuit shown in figure, the current I is, the circuit is having this point A, is connected to a resistor, then to another resistor, then to one more resistor. This point junction is named as P. This is you can call it as B. This is C. So this resistance is 3 ohm. This is 2 ohm. This is 1 ohm. Okay. And it is mentioned that a current I is flowing in this. This current you are asked to find, provided this potential of point A is 24 volts and the potential of point B, VB is equal to 10 volts and potential of point C is 9 volts. Okay? This is the given data. And how can you find? Yes. And currents directions, obviously as current is given here, is I is flowing. What is this current you are supposed to find? Yes, can you try yourself? I will wind up in 10 minutes. How much? What is I? You know, guys are trying. You want some more time? Or can I give explanation? Four options. Let me give you the options as well. First option 6 amps, second option 2 amp, third option 4 amps, fourth option 7 ampere. It's question number 50 actually. Yes. Any other answers? This is the one. Cross check. Right. Okay, listen. So, to find the current from Ohm's law, you can say I is equal to V by R, delta V by R. Potential difference across the resistor by R. So, this potential at this point is given as 24 volts. If you know this, then you can find what is this. I is equal to delta V by R. You don't know this potential. So here you can apply Kirchhoff'S current law. What is this? Kirchhoff'S current law. According to that, from about this junction you can say, so current, so you can take this as I is dividing into I1 and I2, you can take I is equal to I1 plus I2 or if you don't know which is what, you can from the junction you can say this is current is flowing like this, and hence the current across this is potential difference divided by its resistance. Got it? And current across this is potential difference across this by its resistance. Current across this is potential difference across this by its resistance. Did you understand? So if it is a common potential, if you say if it is a junction potential, is some V or Vp or some V if you take, obviously current is flowing in this direction, means this is a higher potential, this will be a lower potential. So in this case, you can write this as current across this C can be taken as delta V by R, and even for that, current across that should be nothing but, you can take this as the first resistor, 1, 2, 3 if you take also, delta V1 by R1, delta V2 by R2, and delta, and for this is delta V3 by R3. But R1, R2, R3 are given. R1 is 3, R2 is 2, and R3 is 3. Right? By using this hint, can you try?
That is V. Did you find common potential? How we did? This is 9, this is 10. So this is 10, this is 9, right? This is 24. So obviously it should flow in these two directions. So it has to flow from this direction, this direction. So you have to take it as I1 is equal to I equal to I1 plus I2. Like that you have to take.
Right? So otherwise you can take it as, in that way, sum of the current should be equal to 0, or I is equal to I1 plus I2. Either way you can take. So if you take this is junction, you can take this as I1, I2, I3. So I1 plus I2 plus I3. I1 plus I2 plus I3 is equal to 0 according to Kirchhoff's current law, by taking these directions, those directions. Otherwise, I is equal to I1 plus I2. The current approaching the junction is equal to current leaving the junctions. In that way, if you prefer to take I is equal to I1 plus I2. So if this is I, then this should be equal to I1 plus I2. So here, I is nothing but potential difference. This is higher, that is lower. So you can take this as 24 minus V by 3 is equal to, for this V, and that is at 10 volts. So you can take this as V minus 10 by resistance is 2. And for this, V minus 9 by its resistance 1. Now you simplify, find V, then you can find I. So what is this? 24 minus V by 3 is equal to V minus 10. That is, if you take LCM here, minus plus 2V minus 18. So directly you can take it as 3V. What is this? Minus 10 minus 18 minus 28 by 2. Again, cross multiply and simplify further. And what will you get? 48 minus 3V is equal to 9V minus 3 times 28. How much? 80? 84? 84. So, 9V plus 3V. How much? Minus 2V. Oh, this is 2, right? 2V. Yeah. Minus 2V. So it is, if you send here, it becomes 11V is equal to, if you send this side, plus 84. So it becomes 120, 132. Is it? 132. So V is equal to 11 ones, 11 twos, 12 volts. Is it clear? Once you find V, then you can find here you want I. This is your I. Delta V1 by R1. Directly you can take it now. I is equal to delta V1 by R. That is 24 minus V. 24 minus V is 12. 24 minus 12 is 12. 12 by R is how much? 3. It is equal to 4 ampere. Or you can use this relation also, guys. You can use this relation also. So we are doing by this using this one. Either way you can do it. So by using Kirchhoff'S current law, you can do it. So okay, it's already 9:30. I'm winding now. Fine, guys. So few more simple questions are given in other exercises. Try to get the worksheets and practice yourself. Already for the day scholars, I think I have sent the soft copy. You can practice with those. Ask the students, try to get the worksheet from the office and practice yourself. Okay. Any questions? Any questions? Any part is not clear for you? You want me to explain anything else? You want me to explain this once again? Or any other point? Girls? No problem? Boys? Astros? So this part. Any problem?